Hello and welcome to Bay College's online lectures for college algebra. This is section 3.2, the graphs of functions. The first thing we're going to do is we're going to look at how do we determine if something is a function just from its graph. And one of the tests that we can do is called the vertical line test. Essentially what we define a function as is that each x corresponds to only one y. That is the definition of a function. So what that means is x doesn't repeat. So let's take a look at this function here. We're going to determine if this function is, or if this graph is in fact a function. We're going to use a vertical line test, which is essentially we take a vertical line and we see how many times it intersects the graph. Well, if I put it here, it only intersects the green part of my illustration here once, or here it only intersects it once, or here it only intersects it once. And if I infinitely move it a little at a time, it's only going to intersect this one time. So for each x, it corresponds to one y. So this side of the graph and this side of the graph, we could see, yes, it passes the vertical line test. For each x, it only corresponds to one value of y. So this is, in fact, a function. Well, let's use the vertical line test to determine if this is a function. Now, we recognize this as a circle, and we just explored circles in Chapter 2. Let's see, if I put a vertical line anywhere on this graph, we see that it intersects it in more than one place. So this is not a function because x repeats. X is this value and this value, or x is this value and this value. Two values of y for one value of x, so the x is repeating. X is this negative value of y or this positive value of y. If we look at this one here, well, this is a line. And if we use the vertical line test, we see, yes, this is a function because my vertical line will only intersect it once, no matter where I put it. This graph here, if we want to determine if it's a function, we can look at a vertical line test and say, yep, it only intersects it once for each value of x. So it is truly a function. Now, what if we're asked to find the domain and range of a function? Well, recall that domain are the possible input values of x. So if we want to look at this function and say, well, what are the possible values of x? On the negative side of the graph, well, we have values of x because this continues on to negative infinity. We have a value of x up until we get to the y-axis. Notice it doesn't cross the y-axis, so there is no y-intercept, which means x is not equal to 0. As we move to the right, we see, okay, we have a value of x as we move to the right. So if we're going to write the domain using interval notation, the only value that's not on our graph is when x is 0. So we have values of x that go all the way to negative infinity, because that's where this arrow points, up to 0, but not including 0, because there is no y-intercept. This, as it goes up, it just gets infinitely closer to the y-axis, but never touches it. And union from 0, because 0 is not included, to positive infinity. And we can see that this goes on for infinity. That's what the arrow indicates. Well, what about the range? What do we know about the range? Well, I see that this line never goes through the x-axis, but I have values above. This line never goes through the x-axis, but I have values below. So we can see there's no x-intercept, which tells me that this graph, its range, is every value except for y. So from negative infinity to 0, union 0 to infinity. So all the way down here, the y values are negative. This arrow points down to negative infinity. As we come up, it approaches the x-axis but doesn't cross. Here, it approaches the x-axis and goes up to positive infinity. So 0 is the only excluded value. So we have the domain and range of this function. And we know it is a function because it passed the vertical line test. Well, we're not going to worry about domain or range on here. This isn't a function, so maybe that's our stipulation in order to find domain and range. Maybe we're just going to look at graphs that are functions. If we look at this, we know it's a linear equation because we see the straight line. And we know this continues on to negative infinity to the right and down. And it continues on to positive infinity, or to the right and left, and up. So our domain, our x values, our possible inputs, are all real values because it continues on to negative infinity to the left, positive infinity to the right. Our range, well, this arrow points down and it continues to go down forever. So our range is all real numbers. If we're going to write this in interval notation, we're going to have negative infinity to infinity, negative infinity to positive infinity. So both our domain and range are all real numbers. In interval notation, negative infinity to positive infinity. If we look at this, well, this was a function, but it's only a segment of a function. And if we're going to determine the domain, well, let's look at the x values. Domain is always x values. It's at 0, and it looks like it includes 0. So I'm going to use a bracket, 0. And it continues on. There are x values all the way up to 2 pi, and this graph is denoted as pi. So I'm going to write 2 pi, and it looks like it includes that point as well. So I use the bracket to show that the endpoints are included. When we look at the range, however, the lowest value in y would be this right here, this negative 2. And the highest value would be positive 2. So our range goes from negative 2 to positive 2. And I'm going to assume that it includes those values. And we always write our intervals from the smallest to the greatest. So negative 2 to 2 would be the range, the lowest value in y to the highest value in y. Range is always